We talked about the four, hold on. So our 4 principles of experimental design are control. We control as many sources of variation other than the factors we are testing for. We need to randomize, which is going to allow us to equalize the effects for unknown or uncontrollable sources of variation. We can control our tolerance to caffeine. We couldn't control how much sugar we ate last night, how much sleep we got last night. Those are things that we realistically could not control for our experiment. So, time's up. Hold on. Okay, so our 3rd principle of experimental design is replication. Not only does that mean sometimes the experiment needs to be repeated, but we need to have more than just 1 strawberry plant or 2 strawberry plants. We need to have a multiple subjects in our experiments. And then the 4th is blocking. If it is necessary, we want to block for factors that we cannot control. We block for age, we can block for gender, we can block for initial heart rate. We maybe could have blocked for people that regularly drink caffeine as opposed to people that do not regularly drink caffeine, but it didn't seem like most of you raised your hand and said you don't have a regular caffeine regimen, which is good, which is surprising. Okay, our OptiGrow experiment is actually on page 321. Okay. An ad for OptiGrow plant fertilizer claims that with this product you will grow juicier and tastier tomatoes. You'd like to test this claim, and you also wonder why might it be able to get half the specified dose? Like if I used half the dose it says and I can stretch that bottle longer, will I still get juicier and tastier tomatoes? So how are we going to set up an experiment for this? Okay. So we need to think through what we need. What do we need for this experiment? Tomatoes, right? Can we just use 2 tomato plants? No, we want replication, right? So replication is part of what we need to do a proper experiment. So how about 12 tomato plants? Does that sound like a good amount of plants? So let's take 12 tomato plants. Okay. What are things that you will need to control about growing these tomato plants? Okay, water, soil, sunlight, shade. So we want to make sure we're planting them in the same soil. We want to make sure we're planting them in an area that's going to get equal sunlight the whole time. Like the ones we're not giving fertilizer shouldn't be in the shade while the other ones are in the sun, right? We need to make sure they're getting an equal amount of water daily. What other things might we need to control? So these are control factors. Okay, so if we're going to plant them from seeds, right, how many seeds we plant in each one, or if we're like getting the like already sprouted plant, right? So whether it's seeds or sprouted plants. How far apart they are. Okay. So what are our treatments? The OptiGrow, right? What are the levels of our treatment? Well, we want a full dose, right? Half dose, and we should have a control group, right? A no dose, right? We should see how the plants grow without any fertilizer. We want to know if a half dose will do the job or the full dose, okay? So those are our treatments and our levels. The treatment is also the factor. So there's one factor in this, okay? We're controlling all these other things. We're giving them all the same amount of water. We're planting them in the same soil. We're planting them in the same spot. They're either inside a greenhouse, right, where all the conditions are controlled, or they're outside in a plot that gets equal sunlight, right? If one plant is going to get more shade, that might affect that plant more. So, and then we need to randomly assign, okay? We have 12 plants and 3 levels. How many plants are going to go into each group? 4 plants, okay? So we take our 12 plants and we randomly assign them. We can say randomly assign to our treatments of the full dose, the half dose, or no dose, which is our control. Okay. Then after time, what do we need to do? Right, we want to evaluate their juiciness and tastiness, because that's what the commercial says, how well they taste. So we need to compare the taste and the juiciness, right? No, gross. We're going to taste all 12 of the plants. We're going to take a tomato off of each of the plants and evaluate their taste and juiciness. Now, where would blinding come into play here?
Not knowing which is which.
Who needs to blind? Who needs to be blinded? Did the tomato plants need to be blinded? No. The tasters, right? So the taste and juicy detectors, right? So the evaluators need to be blinded, which means there's a second person that knows what treatment each plant got, right? So the plants are labeled 1 through 12. That person knows, but the person who's tasting them and rating them for juiciness and tastiness is not aware of what treatment they got, so that they aren't affected by the experiment. Okay, so that's completely randomized. But what if I wanted to, this is completely randomized with 3 levels, right? 1 factor, 3 levels. What if I wanted to see how the amount of water affected it as well? What if I wanted to do not only the fertilizer, but I wanted to test the amount of water we give them every day? So I would get more, like I could do like a cup of water a day or a half a cup of water a day, right? That's, we could do 2 levels of water. So let's look at, what if our treatments are now the OptiGrow and water? The OptiGrow levels are full, half, and none. What levels do we want the water to be?
Water 2 times a day, 1 time a day, and then.
Okay, once a day, twice a day, and let the elements. Right, so let's do once a day and twice a day. We'll talk about how we will set up that experiment with, this has a total of 3 times 2, 6 different groups, right? Because I'm going to have to do full fertilizer once a day, half a day, half fertilizer once a day, twice a day, and then no fertilizer once a day, half a day. Doesn't that make 6 groups? Yes, the 3 levels times the 2 levels gives me 6 groups. So how many plants are going to go into each group now? 2, right? 2 of my 12 plants. So I have my 12 tomato plants. I'll go once a day, water, twice a day water, And then you have once a day full, once a day half, once a day none. Twice a day full, twice a day half, and twice a day none. Okay, and then we are randomly assigning to those 6 groups. Okay, so we randomly assign 2 plants to each of the 6 groups. And then after a while, what do? This is the part that everybody forgets to say, what are we doing at the end of the experiment? We're comparing them. What are we comparing? Still comparing juiciness and tastiness. Okay.
You wouldn't include anything about the water in our comparison?
Well, so what we're measuring at the end is juiciness and tastiness, right? And then we'll know, like, oh, the twice a day no fertilizer was the juiciest, or the twice a day full fertilizer was the juiciest. So because we have them divided into those 6 groups, then we'll look at, right, comparing which group was the juiciest and the tastiest tomatoes. Okay. Causation. The case against smoking can help us with the idea of causation. A retrospective study, so a study that goes back, finds that most people with lung cancer were smokers, was actually inconclusive. They went back and looked at the past. They got inconclusive results about how many people with lung cancer actually were smokers. A prospective study that followed a group of smokers and non-smokers for several years is a little better. But even when it finds greater frequency of lung cancer among smokers, we can't attribute that to the effects of smoking. Perhaps the lifestyles of smokers differ from those of non-smokers in other ways, and those other factors cause cancer. Perhaps there's something about a person's body chemistry that makes them enjoy smoking and also contributes to the later development of cancer. Or perhaps smoking soothes the earliest subtle symptoms of precancerous changes in the body. In other words, the lung cancer causes smoking. Observational studies alone cannot solve this issue, and an experiment is out of the question. Why? Why can't we do an experiment to see if smoking is going to cause lung cancer? Well, all we have to do is take a group of 10-year-olds, randomly assign half of them to be smokers. 10-year-olds?
Yeah.
I don't know.
Oh, so I've seen 10-year-olds.
And half of them to never be around even secondhand smoke, and then wait about 60 years, see what happens. Yeah, exactly, right? We can't do that. We can't do those types of experiments, so we really can't determine causation for a lot of things. Do we believe smoking and lung cancer are associated? Of course. Can we prove that one causes the other? No, because we can't do a survey or an experiment.
You don't think anybody's in the past tried it before?
I mean, there have been some questionable experiments, but I don't think they've tried that one. Here's another conclusion. Of all the pre-college curricula, the highest level of mathematics one studies in secondary school, that's high school, has the strongest continuing influence on bachelor's degree completion. Finishing a course beyond the level of Algebra 2, for example, trigonometry, pre-calculus, AP statistics, more than doubles the odds that a student who enters post-secondary education will complete a bachelor's degree. Propose a study that might enable you to draw this conclusion. What would we have to do in order to prove you are going to be more likely to graduate if you take something above Algebra 2? Just randomly assign some 8th graders. Randomly assign them to take either 8th grade math or Algebra 1 in 8th grade. Whether they pass or not, you continue to move them forward, which actually happens already anyways. And then see what happens. What's wrong with that? If I randomly assign kids to either be in Algebra 1 or the on-level course, which is... Right. Some people who would do well in Algebra 1 are held back because of our experiment, right? And some students who should not be in Algebra 1, they need some support, they need to learn some more skills, are put in Algebra 1 and ultimately set up to fail, right? So a lot of times, an actual experiment is unethical. All we can do is an observational study, and it doesn't allow us to draw causation type conclusions. So, experimental ethics. Most of us have no problem with drawing fertilizer from a tomato plant, but we recoil at the knowledge that treatment for syphilis was withheld from human subjects during the infamous Tuskegee experiment. There are many gray areas in between. Is it okay to use animals for experiments? Does it matter whether they're trying to develop treatments that may potentially save human lives or just develop cosmetics that don't damage people's eyes? Make all your hair fall out. Under what conditions would you consent to try an unapproved experimental treatment? Tons of money? That's it? Only money would motivate you? I mean, what if...
a high enough price on it.
What if you have terminal cancer? Would you try an unapproved experimental treatment?
Take my wins and take my losses.
Yeah? Maybe? So, yeah.
I'm taking my wins.
You'd be really close to dying either way. So.
Yeah, I mean, some people say yes, some people say no. Everybody has their own lines that they draw when it comes to these types of ethics. But what does informed consent mean? Well, informed consent means you have to be aware of the options when you're a part of an experimental trial. You have to know whether you're allowed to be blinded, but you have to know that it's a possibility that you are not getting the treatment. If there's a placebo involved, the subjects have to be informed that it's a possibility that you get a placebo, right? And then at the end of the experiment, you might need to then go through the actual treatment if they determine that it's effective. You might want to be part of the treatment group rather than the placebo group, but you do not get to choose if you're part of a drug trial. So here's some other things. Is it okay to determine whether mastectomies are an effective treatment for breast cancer by randomly deciding which patients have a mastectomy and which patients have a less disfiguring procedure? Should that be randomly assigned to see what's more effective? Is it acceptable to drill placebo holes in patients' skulls so that they and their doctors won't know whether or not they received an experimental implantation of nerve cells as a possible treatment for Parkinson's disease? This experiment was approved.
Wow. Is it
Right?
real?
Was approved. This experiment was approved. They had placebo holes drilled in their skull so that the doctors and the patients didn't know whether they actually got the treatment.
So they would just have like holes in their skull and that was it.
Mm-hmm.
What's the results?
I don't know. Would have to look it up. Okay, how about the Salk polio vaccine trials? Imagine a disease that strikes children, killing many of them and crippling others. Patients were afraid with just cause. Parents took many drastic measures to try to prevent their children from contracting polio. Because the epidemics peaked in the summer, some blamed them on swimming, so children were forbidden to go swimming. One conjecture linked the disease to peach fuzz, so children were forbidden to eat fresh peaches. This is an example of confusing association with causation. There's lurking variables going on. Amidst this climate of fear, someone seeks parental approval to try an experimental vaccine in the hopes of preventing the disease. This vaccine involves injecting a small dose of polio virus into your child. If you were a parent, would you give permission?
Isn't this like
Well, that's what every vaccine is,
they
though.
have to put part of it into your body to protect you?
Right, but this is the first vaccine of its kind, right? So when polio came out, this was the first time this was done.
But someone said yes to that.
Well, that's how it is. with
Yes, yes, lots of people said yes to that.
Crazy.
Okay.
COVID. Isn't that kind of like what they do with COVID-19 vaccination?
Yep. So, but the COVID-19 vaccine is a different type of vaccine, right? It doesn't use the small dose of the virus, right? It uses that mRNA technology.
I feel like with our knowledge now,
So-
any vaccine that we get is gonna have it has a small dose of what it is that we're gonna that we were apparently say yes.
Right. But I don't think every parent would say yes. Go back.
Yes, and mine's actually later.
Where did it go? Where did all my information go? Hold on. So in 1955, one of the authors of our stats textbook was a subject in this experiment. Randomly chosen school districts sought permission from the parents to use their second graders as subjects. Those whose parents agreed were transported to the local vaccination site in the spring. Imagine a long line of kids inching forward to get a shot. This is the author speaking. We stood there watching and listening as each child in turn reached the front of the line and cried when the vaccine was administered. Each of us waited for our turn to cry. About a month later, we made the trip again for the second dose. Another line, another turn to cry. After the summer polio season, the data was checked. It was clear that the incidence of polio was dramatically reduced among those who got the vaccine compared to those who received a placebo injection of a saline solution. So then the federal government mounted a nationwide program to vaccinate all children. In a few years, the disease had been conquered. Now imagine being a 7-year-old and being told that in October, the shots that you got in the spring were fake. So now you have to go get the real ones. Your interest in experimental design is further piqued when you learn that your best friend doesn't need any more shots because he got the real ones the first time. Eventually, you write a statistics textbook. Let's think some more about the ethics here. Some children who got the placebo shot died or were crippled by the disease when the vaccine might have saved them. But how could that be known in advance? If some doses of the vaccine were a little too live, it may have actually caused the disease in children whose parents gave permission in hopes of protecting them. Perhaps one of the most interesting sidebars is that the experiment actually had a second design, in which all the children whose parents approved got vaccinated, and the others were used as controls. So if you said, yes, I approve my kid to get the polio vaccine, they got the vaccine, and then they used the other group as the control group. Surprisingly, the results of this design was not as convincing. It seems that parents with higher levels of education were more likely to give permission and also likely to raise their children in more hygienic conditions. Children reared in less hygienic surroundings were more likely to contract a mild form of polio earlier in life, thus developing natural immunity to the disease when they were older. This rendered the treatment and control groups not identical at the start of the experiment, confounding the results. So they weren't able to tell because there was other issues, other things that, like, the results weren't clear, right? This group had less polio than this group. With the placebo and the treatment, it was clear. So there's no substitute for a double-blinded, placebo-controlled, randomized clinical trial. That's the moral of the story. You can find other ways to do it without that blinding and placebo control group, but those experiments tend to give the most clear results.